Seasonal greetings, and I hope you're enjoying your holidays, your Christmas, your festivities, your merrymaking, and all those things with your family. So, my name is Ronnie Altairi, and you can call me Afroboytex. And today, you're going to look at getting started with RAG and multi-agent generative AI 101. And basically, this is something I've been speaking about quite for some time now, and I felt that I could actually share this video for the people who came for Dev Fest at Kampala, but most importantly missed out this session. Why? Because I didn't speak, and for some other reasons, and but tonight or today you will actually be able to understand what I actually wanted to give back to you. So my name is Ronnie, as I just mentioned earlier, and I do many things, and besides that I want to just identify myself with Google Communities today, and I'm the GDG on campus lead at Makerere University and a computer scientist, like solving problems using the knowledge that I do have. And let's just dive into it. So this is the expectation for today's presentation. You will look at what's RAG, the use cases, the similarities and the differences between fine-tuning, multi-agent generative AI, a blend of that, and we shall also look at the benefits. So to get started, let's have this quote here and statistic. This is according to Gartner research, and we are looking at 80% of people or enterprises getting to use generative AI capabilities and APIs by 2026. What does that mean? That means that positioning yourself right now as a company or as an enterprise, as a startup owner, as an enthusiastic, as an AI person, really, in terms of generative AI, something good. Why? Because we've seen generative AI in text, audio, video, including Sora. Google introduced VO2 the other time, and image generation capabilities like Midjourney, DALL-E, and all those things really bring us to speed to all these generative capabilities of AI. And I believe it's the most interesting part that has actually come through natural language processing, which is a segment of machine learning, which is also another segment of artificial intelligence. So ideally, that's what we shall look at today, and we see that was a raise from just 5% in 2023. So to bring you up to speed, if you typed this in your search, the one in your prompt, basically it could be Gemini, it could be IBM or Granite, that's Watson X, really. Maybe if you're using Amazon Bedrock or SageMaker, or if you're actually leveraging Alibaba has a large language model called Qwen. You could just type this in, and so the one that is not accessing the internet. You could also tweak the settings on ChatGPT. Is it raining in the capital of Wakanda? So first and foremost, what is Wakanda, and what is actually its capital, and what is actually taking place there right now? So that's the rationale of RAG. And for example, you've typed in what's 5 times the temperature of the sun right now. So the sun, I think, is about 5,000, if I'm not mistaken, degrees Celsius, or 50,000 or 55,000. It's around there. And if you just say also 5 times the temperature of the sun right now, you won't be able to actually get a clear answer. Why? Because the temperature keeps varying. It's a varying factor or variable, and you cannot really say that right now the temperature of the sun is this. And that's where RAG comes into play, whereby you'll be able to get the actual temperature that is actually being measured right now of the sun, and be able to actually implement it. So that's the rationale of RAG. So RAG is basically Retrieval-Augmented Generation. So it's giving data retrieval capabilities to these models to pull real-time information. For example, the the information the question I gave, maybe of temperature of the sun, you could actually get to know what's the exact temperature of the sun and be able to use that in your generative capabilities. So it combines the strength of retrieval systems and generative AI. So these three key things that I'm going to mention are basically retrieval, augmentation, and generation. So for example, if a ChatGPT or a tool like maybe ChatGPT doesn't know something, it usually does an educated guess. And basically these tools are trained on large data sets or large corpus of data to make sure that they give information in relation to what they've actually been trained of. So if they do not know something, they usually want to try and make sure they give you an answer. Think of it as someone who wants to always give you an answer, or a friend who always wants to give an answer even though they do not know stuff. So that's what basically chat does, and it searches within itself to see what it has been trained on and what has learned over time to actually give you the information. But with RAG, it doesn't just guess blindly. Instead, it uses external sources, maybe like books connected to it or internet. We saw this, I experienced this personally. Sometime back when ChatGPT had come, I remember I typed in who is the Queen of England, because she had just died. And the response was like, she's still alive. And that was weird, because the person had actually died a few days earlier on, and that's when we had the internet being added into ChatGPT and all those things, whereby it could now actually search the web to make sure that it gives you context, real-time information. And that's where now it's actually trying to be that's why they've been introducing different models and all those other things. So that's the part of retrieval. Augmentation is basically now added onto what AI already knows, so it makes it more smarter. So you basically augment the information that you get, the retrieved information, and make it more accurate and better. Then the last part is generative. Basically, that's what it actually does. So using its skills of generating text, creativity and information, but also English and structure and all those things to make sure it gives you a polished human-like answer, something like that. So this is basically a visualization. At here you have, for example, your prompt. So when you prompt, for example, ChatGPT, instead now of going directly to the generative model, it at the same time goes to the document store. This could be a database, vectorized in form, or you could have internet, you could have any other information really store that you have actually connected to your prompt or to your APIs or to your large language model, basically whatever you're using. And this checks the context. This is now like the context. It checks this information first before it even gives you the response. So it combines this response. So it combines this information from here, from the retrieved document store. Then after, it puts it in the large language model, and then it augments and then generates your response at the end of the day. So ideally here, instead of looking through its information first, what it already knows, it just goes to the document store first to do the context and generate maybe information that could be related from that store, and be able to retrieve and then add it into the LLM model and be able to give you a response. So it matters. Why does it really matter in the first place? Because the traditional models really do have constraints, out of date training data. These are like the two key reasons why RAG matters. Basically, it is really expensive to actually train data sets. You hear of 10 billion parameters, 70 billion parameters. That's a lot of voids being trained for a data set, and the more the parameters of the data sets, the more expensive the training, the costs, that is actually involved, and information also keeps changing over time. For example, when ChatGPT had just actually came, it will only give information up to like 2021, up to when the data sets were actually up to dated, or the information actually trained on, and couldn't give information which was really up to date, and that's where RAG comes in. And it also does reduce hallucination. Hallucination is basically kind of like you prompt something, but it gives you something else, maybe which is biased, or it just goes overweight. And for example, you could maybe give it as a prompt of, give me a story of maybe Middle Age Earth, or give me a story maybe of maybe Professor, let's say Dumbledore, for those who are Harry Potter fans, and then instead it actually gives you maybe Middle Earth, that's basically the Hobbit people, instead of actually Professor Dumbledore. So and all those things really bring in the information, the hallucination of AI, because of the data sets that's actually been trained on, and RAG comes to actually reduce on that, to give it more real-time updated information, which is information rich and grounded theory, or grounded information. So another example with ChatGPT with the browsing capabilities, already seen this. So for example, if you texted this in your prompt in your ChatGPT, basically, let's see, let me first go back. So if you texted this for example in your prompt, let me just open here ChatGPT. So ChatGPT now can access internet. So what you want to do is basically first maybe change the model. So if you want to change the model, just come here, you switch the model, search with web. You can see this is why you don't have to use the web. Let me see, search the web, auto without the web. I'm looking for one that doesn't have web. View tools. Okay, let's just see what is Willow. Let's see what it brings. What is Willow from Google? So it's telling us AI-driven conversation platform. So this is the hallucination I'm actually talking about here. So as we all know, Willow is not an AI-driven conversation platform really. It's a quantum computing chip that was introduced recently. And what does this tell? This is where now RAG comes into play, being able to search the internet. So if, for example, I typed in again with search the internet, because you can see this is Willow from Google. So if I typed in the same and I did maybe what is Willow from, what is Willow from Google again, and this time round I do search the web instead of actually getting what it has actually been trained on. This is what I was saying. It's doing an educated guess in a way that it's actually trying to tell you this is because they know Google is more of related to programming, tech things, maybe AI and all those things. So it's telling it's an AI-driven conversation platform, which is wrong. And if you just copy paste on this, you'll actually get it wrong. But sure, when you do the search from the web, this is where now RAG comes into play. You'll be able to actually know that it's a state-of-the-art quantum computing chip that has just been unveiled. That's just been unveiled, and it's fascinating to see how actually it even gives you the sources actually of where it has actually gotten the information from. How RAG can actually help out in such instances. So going back to our slides, So you could actually implement RAG on device machine learning. This is basically a tiny ML or something like that. So what does that mean? That you could actually store your information, or you have local data that is stored on your smartphone. It could be your machine learning project, could be even Raspberry Pis, it could be any projects that you're working on which you use maybe tiny ML or on device machine learning to be able to get context from the data and be able to actually output information, and RAG is very helpful in that regard. So from here and onwards, I'm going to introduce to you multi-agent generative AI, but I hope you're still with me, because this will just continue the discussion from RAG and multi-agent systems. So the concept of multi-agents is basically where you have multiple generative agents doing this different things, then coming together. So tools like Llama, Watson X from IBM, Sonnet from Anthropic, Hugging Face Transformers, Sora from OpenAI, Polygemma from Google, Langsmith from LangChain. LangChain has a couple of tools that you can actually get to use with no-code solutions in regards to creating your own agents and AI framework. So basically, you should explore. They also have something called LangGraph, Langsmith, LangGraph, Langscape, something like that, and a couple of tools that you can actually get to use to make sure to introduce this. So multi-agent systems basically use several agents to actually achieve something. That's the whole essence. You could have maybe, for example, one that is good at storage, one that does mathematical functions, and one maybe that does the internet search. So this is kind of like a mixture of experts, if you've heard of that term. So basically a mixture of experts is something whereby you have one, you introduce getting meaning that you have like different experts doing different things, like different agents which are specifically trying to do one particular task, but you have a gated network whereby in there you control. If for example the prompt is about mathematical computation, you will send that specifically to a mathematical agent, something like that. And if it's something related to querying the internet for searches and all those things, you will send to the search agent, something like that. And this is all coupled with with generative AI to make sure you continue achieving different things. And the way how they work is through a chain of thought prompting. So chain of thought prompting is basically how these multiple autonomous agents like AutoGPTs and other things do work. They break the problem into different sequential steps. Just like if you're going to add 10 to, if you're going to multiply 54 times maybe 30, you could maybe first do 50 times 30, then you also add a 4 maybe times 30. Or if you're going to add 70 to 96, you first do 70 plus 90, then you exclude the 6, then you come and add the 6 later. Or you could do 100 minus 97. You have maybe any way how you actually figure it out. This helps in a way of breaking down problems into smaller problems that can actually be manageable, that can actually be solved. And that's the whole essence of chain of thought prompting. So let's look at the difference between RAG, fine-tuning, and embedding. So RAG, we've already seen what it does, and fine-tuning now comes into play in a way that you actually get to retrain the model in some other data set that can actually specialize in that particular domain, something like that. So here you just tweaking the parameters, make sure it may be with new data to make sure that it actually specializes in that particular area of training. So the main difference here, you'll see that it is specialized text generation between RAG and fine-tuning. So for RAG, basically it generates text using the retrieved context. For this one, it's a specialized text generation from the models you've actually fine-tuned with that more specifically a large language model. And for embedding, you're basically getting to to represent data, basically, kind of. For example, you could have numerical vectors to represent a database, something like that. So you just encode the relation. It's kind of like creating relations between data to make sure you have like meanings from all those different data sets or data points, I would say. And it's good for basically semantic search for documents, and that's how that's the main difference really between these three. So I already gave an example of AutoGPT. You can actually search for this one on GitHub and actually get to download it. And then just to leave you with this, something you just have to think about. Imagine what AI is capable of doing right now, but imagine if it actually had superpowers. So superpowers, I mean, for example, if it could actually do whatever it wanted to do to achieve what it wants to achieve. Imagine how it would actually go beyond teaming up with different experts. For example, let's say superheroes usually come together to do stuff. Now imagine you have a fleet of superheroes who are basically AI agents that can actually achieve you what you want to achieve. So some of the benefits of RAG include more accurate information, and for multi-agent, it's basically distributed task handling, leading to efficiency. Industrial use cases include health, finance, and really many other things really. It can help with maybe education, climate related. RAG can be applied in every specific, in any context or in any domain out there. So some challenges that you should consider: basically data quality is really key, ensuring that the retrieved context or the information you actually give as the context is actually up to date. Then agent coordination is really hard, making sure, for example, if you're going to do a multi-agent system that maybe has different inputs for different models or different agents, so you will have to manage these conflicts to avoid something like wherever you're sharing resources, something called is it racing? No, yeah, racing. So racing basically whereby you access the same resource at the same time, and then some issues actually get to happen. So in that sense, you need to make sure you manage those conflicts. And at the end of the day, really this is expensive endeavor also to try out. Implementing all these tools, however much it is still cheaper than training the models, it's still expensive for small businesses to actually adopt. That's why now you need to start small as a solution. So for the data quality, you just need to do periodic data updates and checking the data consistencies and all those things. And for the agent coordination, you just have to do a robust coordination protocol, something that can actually help you. For example, like the mixture of experts thing that you talked about, having like a gated network that can actually control something like a middleware that can actually control all these agents, like an agent that controls all these agents. Here is some hackathon that you could actually try to check and test your RAG skills. So basically using Mistral, LLM, and Cortex Search. I've actually used Azure AI Search for my chatbot that I created. Maybe I could also let me just share this chatbot with you. It is at Impampe Azure website. So I also happen to be a Microsoft student ambassador. So this is a chatbot, a RAG chatbot that I implemented basically using Azure AI Search and Azure OpenAI. So if you asked it, you could actually ask and test it. Hi, Pampe. Basically tell you more information about Mpampe and really anything that's to do with creating applications. So Mpampe is basically a crowdfunding startup that I'm trying to build. So yeah, so if you want to test your skills, I would recommend you to try out this Snowflake and Mistral hackathon on DevPost that you could actually participate in personally. And yeah, let's do this. So this is where I get to end. If you scan this, you'll actually get to connect with me more and most importantly, please, if you've enjoyed this video up to this end, please subscribe and then share. And I'll be also speaking about different other things, specifically in the topics of ethical AI and responsible AI, also, and AI in governance and all those things. So thank you so much. My next video will be about mixture of experts and how you can actually even use the different experts or different agents to actually achieve one thing, but also shall be talking about how to use quantum computing, or how quantum computing can actually accelerate generative AI, cryptology, Web3, and all those things. So thank you so much. See you in the next video.